we are going to demonstrate a program on combinational logic. So first we have to know what is combinational logic. A combinational logic is one for which the output value is determined solely by the value of the inputs. It consists of input variable, output variable, logic gates and interconnections. Interconnected logic gates accept signals from the input and generate signals at the outputs. For a capacity of neural network, we must know neural network architecture that save time and allow for less expensive circuitry. There are two neural network architectures. First one is a multi-layer multiple output feed forward, and next is multi-layer single output feed forward. And next we are going to see advantage of one network on another. There are two types of forward neural network architecture that were used. The first type was a feed-forward neural network that was fully connected. And the second type partitions the problem into smaller independent subtasks, and the neural network is designed to implement each subtask. Fully connected network has a goal to combine the training of every output bit and thus use fewer-based and fewer neurons. Goal of type 2 was that each neural network would look for a smaller number of patterns, thus reducing the training time as well as the number of neurons. Next, we are going to see program. In the program, we are doing program with MATLAB. MATLAB stands for matrix calculation. So, as you all know the syntax of MATLAB. First one, we are starting with CLC. CLC stands for calculation, and then clear all. Clear all means we are clearing all the remaining memory which are back or which are busy in some other program. And close all means we are closing all the running programs, and then we are giving the inputs. By input x is equals to input, enter the number of inputs. What number of inputs we want, we can enter in this. And then we are going to give the size of hidden layer. Size of hidden layer is in the matrix form 4, 3, 1. And then we are going to do weight initialization of each input. How we do this? We do this by we are taking random value for weight of input 1. By W1 is equals to rand HLS V1 and 2 into V1 minus 1 plus 2. But there is a condition on that. If V1 is equals to input x plus 1, then we can take this. But if it is not, then we have to take W1 is equals to random HLS V1 2 into V1 plus 2. And V1 is a variable which is in a for loop, and it starts from 1 to going to input x plus 1. And then we are generating the weight of input 2 by random value of 1 HLS V1 plus 1. And then we are creating a new variable, data is equals to 0.5, a is equals to 1 and sx is equals to 0. And then what we are going to do, we are giving the output hidden layer. By this we can see the hidden layer output. By input u is equals to 1 and training set. Sum h is equals to W1 into input u, in transpose of input u, and then transpose of whole W1 into input u. And then at last output of hidden layer is 1 upon 1 plus exponential of sum h. We are doing because this is a sigmoid function. And at last we are seeing the output layer by input h is equals to 1 and output h. And sum out is equals to W2 into input h transpose of transpose. And then we are going to see the error value. Error value is the difference between target value and observed value. So this can be calculated as delta out is equals to out into 1 minus out is into training out minus out. And then delta of hidden layer is delta out into W2 into input h into 1 minus input h. And then we are trying to reduce the error value by updation of weight. So we are updating the weight in output layer and in the input layer. for what we are in. First we are going to see the updation of weight in output layer by W2 is equals to W2 plus neta into delta out into input H, and for the hidden layer there is a for loop. By this we can update the weight of hidden layer, and by this we can reduce the error value, and at last we are going to see the output of this program. In this it is demanding number of inputs. As you see, there are three graphs obtained. These three graphs are of three networks. First one is of fully connected network, and then second is for one output per network, and the single bit per network. So we can say that a single bit per output network uses less overall neurons to perform the same function as a multi-layer network. So we can say that a multi-layer network is best for this. I hope you can understand our program. Now we are going to tell you the multi-layer multiple output network. In this, there are multiple outputs generated. So this is a program for multiple layer multiple output network. In this program, just as the previous program, there are CLC, clear all, chromosome, input x equals to input, enter the number of inputs. In this also we have to enter the number of inputs what we want. And then in this there are 12 hidden layers, and the size of hidden layer is 12. And then we are weight initializing by W is equals to rand HLS 2 into input x plus 2. This is the weight of first input, and the weight of second input is rand input x plus 1 HLS plus 1. We are creating a new variable, neta is equal to 0.5, a is equals to 1. We are beginning the for loop for x equals to 1 to 15,000, and in this what we are doing, we are generating the output hidden layer, and then output layer, and at last we are doing delta. Delta is for error value. Error value is the difference between the target value and the observed value. As you know, for reducing the error value, we have to update the weight of each layer. In this, we are updating the output layer by W2 from T to something is equals to W to T plus neta into delta out T into input H. And for hidden layer, we are just doing the for loop. In this, by this for loop, the hidden layer update, and at last error value is minimized, and we can get the better input variable. At last we are going to tell you the output of this program. This is the graph for multi-layer multiple output network. What is this? By this and the single input network, we can say that type 2 neural network look for a smaller number of patterns, and they thus reduce the training time as well as the number of neurons. So type 2 network is the best network architecture. Now we are going to see the cryptography using sequential machine. A sequential machine can be used in cryptography, where the input data stream is the input to the sequential machine, and the state determines the output-input relationship. The state of the sequential machine can be used as key, and the data can be used as an input to the sequential machine. The relationship between different output and states can be any random, but unique sequence to the encryption. There are as many state units as there are output units in the network. The connection between the output and state units have a fixed weight of +1, and learning takes place only in the connection between input and hidden units, as well as hidden and output units. The reason for using sequential machine for implementation of that is that the output and input can have any type of relationship, and the output depends on the starting state. The starting state is used as a key for encryption and decryption. A 3-bit encryption machine was successfully built using an ANN-based sequential machine. Input is 3-bit data and sequential machine has 2 states. So first we have to know what is sequential machine and how it can be used in cryptography. A sequential machine can be used in cryptography where the input data stream is the input to the sequential machine and the state determines the output-input relationship. The state of the sequential machine can be used as key and the data can be used as an input to the sequential machine. The relationship between different output and states can be any random but unique sequence providing security to the encryption. There are as many state units as there are output units in the network. So you can say that it is a fully connected network. The connection between the output and state units have a fixed weight of +1 and learning takes place only in the connection between input and hidden units as well as hidden and output units. The reason for using sequential machine for implementation is that the output and input can have any type of relationship and the output depends on the starting state. The starting state is used as a key for encryption and decryption. In this program, a 3-bit encryption machine was successfully built using an ANN-based sequential machine. In this, input is 3-bit data and sequential machine has 2 states, either 1 or 0. Letter A to H were used to represent all the possible 3 bits input. If the state is 0, then the input letter is shifted by 1 to generate the encrypted letter, while if the state is 1, the letter is shifted by 2. During this operation, the state is automatically switched, and in this program we have to use the starting state as 1. Now we are going to see the program, how it is be done. We done our program in MATLAB, that stands for Matrix Laboratory. In Matrix Laboratory, the syntax is CLC for calculation, and clear all is for clearing all the memory which are busy in some other program, and close all means we have to close all the running programs. For this, input is 3, that means number of bits of data is 3. So output is also 3. In this, number of states is 2, and for generating number of bits per state, we have to looping our program for temp, and temp is a one variable which is running from 1 to 100. If 2 to the power temp is greater than or equal to state, then state is equals to temp. And in this, size of hidden layer is 6. Then we have to initialize the weight of inputs. Initialization of weight of input of 1 is W1 is equals to rand HLS input x plus states plus 1, where rand stands for any random value, and W2 is equals to rand output x plus state HLS plus 1. And we generating new variable neta is equals to 1, a is equals to 1, sx is equals to 0, and t is any array which we can put any size. Then we have to initialize the training set. And for output hidden layer, what we have to do? We have to do input u is equals to 1 and training set in the matrix, and sum h is equals to w1 input u transpose of transpose, and the function used in this is a sigmoid function. So output of hidden layer is 1 upon 1 plus exponential sum h, and output
layer is input h is equals to 1, output h, and sum out is equals to W2 into input h transpose of transpose. Out is equals to 1 upon 1 plus exponential sum out because it is a sigmoid function. And we are generating the error value. Error value is known as delta and it is calculated as difference of target output and observed output. Then after generating the delta, we have to reduce the delta value by updation of weight. So updation of weight is done in two manners, first in the output layer and second in the hidden layer. So updation of weight in output layer is for t is equals to 1 to output x plus state, and W2 is equals to t is equals to W2 plus neta into delta out into input h. And for hidden layer, we have to looping our program. And for testing the program, we have to use our starting state. As I already mentioned, the starting state in our program is 1, and then we have to enter the word. After entering the word, it is going through our program that if the state is 0, then the letter is shifted by 1, or if the starting state is 1, then the letter is shifted by 2. So you can see in this program how the letter and the states determines our encrypted data. Now we are going to see the output of our program. This graph shows that our network is a fully connected network. And then we have to enter our starting state. So starting state is 1. And then we have to enter any word which we have known to be decrypted. Suppose that it is Archita. Then we are going to see what is encrypted data. The encrypted data in this is CBEABAC. This encrypted data is according to our program strategy that if the starting state is 0, then the letter is shifted by 1, and if the starting state is 1, then the letter is shifted by 2, and states of letters are already switched by themselves. Cryptography using chaotic neural network. According to binary sequence generated from a chaotic system, the weights of neurons are set. The chaotic neural network can be used to encrypt digital signals. Network features are high security, no distortion, suitable for system integration. The encryption scheme belongs to value transformation. Chaotic neural network offers greater increased memory capacity. Each memory is encoded by an UPO on the chaotic attractor. A chaotic attractor is a set of states in a system state space with very special property that set is an attracting set. A chaotic network is a neural network whose weights depend on a chaotic sequence. A chaotic sequence highly depends upon the initial condition and the parameter. So x0 is equals to 0.75 and mu is equals to 3.9 are set in this program. It is very difficult to decrypt an encrypted data correctly by making an exhaustive search with knowing x0 and mu. Depending upon a chaotic sequence, a weight matrix and a bias matrix is obtained and the net input is obtained. A hard limiter is applied as a transfer function in order to obtain the digital encrypted data. Chaotic neural network can also be used to decrypt and encrypt data such as images by converting it into a single vector. So, we can say that chaotic neural network is one of guaranteed high security. Now we are going to see the program of cryptographic using chaotic neural network. Chaotic neural network programming is done in MATLAB. So, as you already know, CLC is for calculation, clear all is for clearing all the memories which are busy in another program, and close all is for closing all the running programs. In this, input is already given, so input is in a matrix form 11, 23, 37, 45, 68, 25, 236, 58, 59 and 90. And we have to generate a chaotic sequence. So for that we have to give x0 and mu value. So x0 is 0.75 and mu is equals to 3.9 and length of input is 1. And for generating the network, we have to loop our program in this way so that it can be show that it is a chaotic neural network. In this, dx c1 is equals to hard limiter sum of weight I into input x c plus theta I. And depending on that, our encrypted data using a chaotic neural network is obtained, in which the x0 is 0.75 and mu is equal to 3.9 are set. Now we are going to see the output of our program. So you can see that as input is given already in this program, and depending upon x and mu 0, we are getting our output. So you can say that output is an encrypted data based on input and x0 and mu value. In the next program, we are seeing the decryption of the same data by using chaotic neural network. Now we are going to see decryption using chaotic neural network. It is same as encryption using chaotic neural network. The difference is only that the output obtained in chaotic neural network act as input in decryption using chaotic neural network. x0 and mu value are as it is, and what is input in the encryption using chaotic neural network is obtained in this as decryption using chaotic neural network. All things are same, so we can say that it is very difficult to decrypt and encrypted data without knowing x0 and mu, because x0 and mu act as a very smart role in this, because it is only two things which determine our input or output. Now we are going to see output of our program to prove that it is same as encryption using chaotic neural network. The difference is only that what is output obtained in encryption using chaotic neural network act as input to the decryption using chaotic neural network. So you can see that what is output in the encryption using neural network, chaotic neural network, is input in the decryption using chaotic neural network. Value of x and mu remains same, and the output obtained in this is same as input in the encryption using chaotic neural network. So we can say that chaotic neural network is of high security and we can use it in cryptographic using neural network. Cryptography, because in cryptography what we want only security, no distortion of data. So chaotic neural network is one that satisfy all these things.